Hello. So in this video, we are going to talk about how to multiply rational expressions. So one of the key concepts that we use to multiply and to divide rational expressions is factoring. So if you need a review or refresher on how to factor trinomials, there are 2 videos posted, so feel free to take a look at those before you get into this section so that you are comfortable factoring so that we can multiply rational expressions. So we're just going to start with an example. I think that's the easiest way to show you how to go through the process. And I have listed the steps out here for you. So to start, we have x plus 4 over x squared minus 16 times x plus 2 over x squared plus 6x plus 8. So we have 2 rational expressions and we're multiplying them together. The first thing we want to do is we want to factor all parts of both expressions. So in the first one, the numerator is factored, x plus 4, we can't do anything there, but the x squared minus 16, we can factor into x plus 4, x minus 4. So we want to do that. And then the second expression, our numerator x plus 2 is going to stay the same. Our denominator, x squared plus 6x plus 8, is going to factor to x plus 4 times x plus 2. So that I have listed as step 1. Step 2, and I like to do this as step 2 because you'll see we're going to cancel some things out and we may not get a true idea of what x values make the expression undefined. So I like to find that before we cancel anything out. So step 2, I'm going to take all of my denominators and just off to the side, I'm going to set them equal to 0, and I'm going to solve for x. So I have x plus 4 equals 0, so I get x equals negative 4. I have x minus 4 equals 0, so I get x equals 4. And I have x plus 2 equals 0, so I get x equals negative 2. These values, the negative 4, the 4, and the negative 2, if I were to take them and plug them back into my original problem, what I started with, I would find that I have 0 in the denominator of these expressions. And if you recall, you cannot have 0 in the denominator of an expression. It makes the expression undefined. So what I've done is I've found the x values where the expressions are undefined in step 2. Okay, so that's done. Step 3, I'm going to cancel now any like terms. So I want to first look within the fraction itself. So the first rational expression, I have an x plus 4 on the top and I have an x plus 4 on the bottom. So if I do x plus 4 divided by x plus 4, that actually comes out to 1. So those get canceled. Then I'm going to cancel the second expression. I have an x plus 2 and an x plus 2. So again, I get my 1. And I want to check the diagonals now. So in this case, there is nothing that cancels diagonally. Everything that can be canceled has been canceled. So I'm done step 3. Step 4, I want to multiply across. So in my numerators, I have a 1 times a 1, so that gives me a 1, and then in my denominator, from the first expression, I have the x minus 4, so x minus 4, and then in the second expression, all I have left is the x plus 4. So my final expression simplified is 1 over x minus 4 times x plus 4. So step 4 is done. And then step 5, I'm going to go back to this list that I made of x values where the expression is undefined, and I'm now going to include those in my final answer as what x cannot equal. So I'm going to say I 1 over x minus 4 times x plus 4, but x cannot equal negative 4, 4, and negative 2. And step 5 is done, and that is my final answer. I need to make sure I include those x values that make the expression undefined so that if I were to pick random x values, I know that those negative 4, 4, and negative 2 cannot be used. And you'll see in my final answer that x plus 2 factor canceled out, so it's not even shown there. So if I had waited until the final answer to find my x values that made the expression undefined, I may have forgotten that negative 2, which is why I like to do it as the second step to just make sure that everything is accounted for. So step 1, again, we want to factor. Step 2, we're going to find the x values where the expressions are undefined. Step 3, we're going to cancel within the fraction and diagonally. Step 4, we're going to multiply across. And then step 5, we're going to list the x values that make the expression undefined. If you go through all 5 steps, you'll have your final answer. So let's take a look at another example. I have x squared minus 10x plus 21 over x squared plus 9x plus 20 times 3x plus 12 over x squared minus x plus 6. So step 1, I don't have the steps listed here, but step 1, we want to factor. So we're going to factor all the numerators and denominators. So my first numerator, I get x minus 7 times x minus 3 over x plus 4 times x plus 5 times, now here 3x plus 12, I'm just going to factor out my GCF, so really I just have a 3 times x plus 4 over x minus 3 times x plus 2. Okay, so step 2 said to look at all of your denominators and just off to the side set them equal to 0 and solve for the x values that make the expression undefined. So x plus 4 equals 0, so that gives me x equals negative 4. X plus 5 equals 0, gives me x equals negative 5. X minus 3 equals 0, that gives me x equals 3. And x plus 2 equals 0, so I get x equals negative 2. So those x values are the ones that make my expression undefined. I'm going to come back to that. So I'm just going to keep those off to the side. Okay. Step 3, I want to cancel both within the fraction and cross diagonally. So in my first expression, my first fraction, nothing cancels. I have no terms that divide out. And same with the second, but if I look diagonally, so I'm going to compare my numerator from the first fraction to the denominator of my second fraction, I can see that the x minus 3's cancel out. And I'm going to do the same thing, the denominator from the first and the numerator from the second, and I can see that my x plus 4's cancel out, which leaves me with, across the top, my x minus 7 times 3, and then across the bottom, x plus 5 times x plus 2. So I've multiplied across, step 4, and now final step, I'm going to go back to those x values that I have off to the side, and I'm going to say x cannot equal those. So x cannot equal negative 4, negative 5, 3, and 2. So I get 3 over x minus 7, 3 times x minus 7 over x plus 5, x plus 2, where x cannot equal negative 4, negative 5, 3, and 2. So let's take a look at one more example, and I think that should cover pretty much how we multiply rational expressions. So here I have 4x squared minus 16, so I want to factor my numerator. I'm going to start by factoring my GCF, so I get 4 times x squared minus 4. Now, if you recognize the x squared minus 4 is the difference of perfect squares, so that can actually be factored even further. That's going to factor into x plus 2, x minus 2. So when you factor these, make sure you're factoring them as far as they can go. You don't want to just factor out a GCF and stop and then have something factor even further. So we have the 4x squared minus 16 actually factors twice to 4 times x plus 2, x minus 2. And the denominator here is going to give us x plus 2, x plus 6 times, I'm going to factor out a 2, so 2 times x, you know what? This should be a plus 12. So 2 times x plus 6 over 6 times 3x plus 1. So I'm going to go off to the side and I'm going to say, okay, well I know x equals 2, x equals negative 6, and x equals negative 1/3. So I got those values just by setting my denominators equal to 0 and solving for x. And now I'm just going to cancel. So I have an x plus 2 and an x plus 2. Those cancel. And I have an x plus 6 and an x plus 6. And then I have a 2 and a 6. So the 6 becomes a 3. So 2 into 6 is 3. So now I'm just going to multiply across. I have a 4 and an x minus 2 on the top. And on the bottom, I have nothing in the denominator of the first fraction, but I have a 3 times a 3x plus 1 in the second fraction. And then, of course, I want to say x cannot equal 2, negative 6, and negative 1/3. So there you have the final answer for this when I multiply 4x squared minus 16 over x squared plus 8x plus 12 times 2x plus 12 over 18x minus 6. I get the simplified expression 4 times x minus 2 over 3 times 3x plus 1, making sure to note that x cannot equal 2, negative 6, and negative 1/3. So that is basically an overview of how you multiply rational expressions. I will be posting another video on how to divide rational expressions. The good news is if you know how to multiply rational expressions, you can divide rational expressions. We're just going to add one minor step that I'm pretty sure most of you already know just from how we divide fractions in general. So we take that step into account, and then it basically becomes a multiplication problem. So that video will be coming shortly, but for now, we have how you multiply rational expressions. If you have any questions, feel free to email, and hopefully this was helpful. I will see you soon. Thanks.